Hi everyone. In this video we will learn about electronic configuration. Electronic configuration is known as the backbone of chemistry. If you understand how to arrange electrons around the nucleus, you understand a lot of chemistry concepts. So make sure you pay attention, take good notes. To start with, electron configuration means arrangement, So we will be talking about arrangement of electrons around the nucleus. We have talked about different theories or how the nucleus evolved. If you remember, we had a solid sphere model. Then we had the plum pudding model where we had protons and electrons embedded in the nucleus. And then the Rutherford said there is nucleus and the electrons revolve around the nucleus. Okay, but then we have a Bohr's model. So Bohr's model was planetary model. He was the one who said that electrons travel around the nucleus in a particular path, and that path is called orbit. So just like planets orbit around the sun, okay, the electrons orbit around the nucleus. So this electronic configuration that we will learn in this unit is based on Bohr's model. Okay, but as of now, this model is not good anymore. The latest model that we know is called mechanical model, and according to the mechanical model, there are no really orbits. They are all over the place, so it's hard to find the location and momentum of an electron. Anyway, going back, so the most specific way of describing where electrons are found. So that's what we will learn. We will try to learn that if this is the nucleus, then where exactly the electron is around that nucleus. So we will be very specific that which electron is sitting right here, which electron is sitting right here, and even within that energy level or orbit, there are sub-levels. So around the nucleus, we have these orbits. The orbit that is close to the nucleus has less energy. As you move further away from the nucleus, it has higher energy. Okay, it has higher energy. So since they have different energies, they're called energy levels. So what you see here is, you see energy level 1, you see energy level 2, you see energy level 3. Okay, now how do you know that one element has how many energy levels? It depends on the period any element is in. So let's say hydrogen is in period 1. Okay, then you have period 2 and 3 and 4 and 6 and 7. Okay, so anybody who is in period 2 across the board has 2 energy levels around it. Anyone who is in period 3, okay, has 3 energy levels around it. 1, 2, 3. Anyone who is in period 4 has 4 energy levels around it. Okay, so this is how it goes. And as I said, that the energy level that is close to the nucleus has less energy, and as you go further away from the nucleus, it gets higher in energy. So what is the energy level again? It is the main path around the nucleus where electrons travel. So parts, when we do the electronic configuration, it will be written out like this, 1s2, 2s2, 2p, 5. I'll teach you how to come up with this. But once you write this number up in the front is called coefficient. So this number gives you the number of energy levels. Okay, so this is your energy level. This letter S, S and this P, they represent sub-levels. And these exponents represent the number of electrons. So sum of all the exponents is the total number of electrons. Okay, so this is what you need to know for these notes. Before I move any further on, I will explain. So these notes doesn't really explain you much. Let me explain how it works. So we have a nucleus, and as I said, this is the less energy level. Energy level with less energy. Then you have So I'm going to go up to 4 energy levels. And this is energy level 1 and 2 and 3 and 4. How many maximum? You can go up to 7 because there are 7 periods. Okay. So this main thing is called energy level. Bohr explained this whole process in terms of quantum numbers. So the very first one is called principal quantum number. Okay. According to principal quantum number, we represent the energy levels by n. So this is n1, this is n2, n3, and n4. Okay, he gave us a formula of 2n square to find out that how many maximum electrons you can fit in here. So if n is 1, and I want to plug the number in, so 2 times 1 square will be 2 times 1, that's 2. That means maximum electrons you can put in here is 2. Okay, then if I want to find out how many electrons I can put into the second energy level, so 2n square, so 2 times 2 square, which is 4, so it's 8. So maximum electrons you can put is 8, 18, and 32. So you need to know that 2n square gives you the total number of electrons that can be placed in any given energy level. Keep in mind that the one that is close to the nucleus has less energy, and the one that is further away from the nucleus has more energy. Okay, so these are the maximum number of electrons that you can put in here. And 1 can take 2 and 2 can take 8. Now these energy levels are divided into sub-levels. Okay, so within the energy level there are sub-levels. Just like, you know, we have a Virginia state, okay, and then within the state you have county. All right, so if somebody wants to find out where are you right now, so you are in Virginia, then within Virginia you are in Fairfax County, and then within Fairfax County you are in the city of Annandale, and within the city of Annandale you are at Annandale High School. So this is what we are doing. We're trying to locate the electron. So we know that electrons are revolving around the nucleus. So we first of all know that the electrons are revolving around this main path. Okay, and then this path is further divided into sublevel. So how many sublevel? There are a total of 4 sublevels. Okay, there are a total of 4 sublevels, and they're called S, P, D, and F. These are small letters, and they represent their shape. So S means spherical. Okay, P means peripheral. You don't have to memorize this. I'm just giving you extra information. D means dumbbell shape. So this is what it is, S, P, D, and F. Now energy level 1, this is energy level 1, has only one sublevel, which is S. Energy level 2 has 2 sublevels. Energy level 3 has 3 sublevels. Energy level 4 has 4 sublevels. There are maximum of 4 sublevels. So even if you have the energy level 5, it will also have only 4 sublevels. Okay. So every energy sublevel starts with S first, because S has least amount of energy. Then you have P, and then D, and then F. Okay, so I'm going to erase this a little bit to clean up. As I'm telling you that we have energy levels, this one had all 4, P, D, and F. Okay, so again, to explain this further, energy level 1 has sublevel S. Okay, let me do it the other way around. So when I plot it on the energy graph, let me plot it on the energy graph. So if this is the energy graph, energy increases this way. Okay, energy level 1 has only sublevel 1s. Energy level 2 has 2s and 2p, so it's divided into 2 sublevels. Energy level 3 is divided into 3s, 3p, and 3d. Energy level 4 has 4s, 4p, 4d, and 4f. So this is how it is divided. Okay, so this is pretty much it. So if I have, let's say, 3 electrons in my hand, and I want to distribute those electrons, I will first of all start with the lowest energy level. This rule was given by Aufbau. Aufbau is a scientist who said that the electrons always fill in the lowest energy level. So I cannot start filling it in from here. So if I go here, I go to energy level 1. Energy level 1, I see the sublevel S. And S, okay, I didn't tell you how many electrons S can take. So I have sublevels, and this is the number of electrons. So I have 4 sublevels, S, P, D, and F. S can take 2 electrons, P can take 6, D can take 10, and F can take 14 electrons. This is the maximum number of electrons these sublevels can take. Okay, they can take less than that, but no more than that. Okay, so you can take less than that, but not more than this. So I'm going back. So I know that S can take 2, P can take 6, D can take 10, and F can take 14 electrons. I have although only 3 in my hand. So I'm going to start here. S can take 2. Okay, so if S can take 2, I'm going to put 2 for S, and then I jump up to a higher energy level. When I jump up to the energy level 2, I will go to S first. Why would I go to S? Because S has less energy than P, which has less energy than D, which has less energy than F. And electrons always start from the lowest energy level. So I put 2 in here, okay, and I jump up. I have only 1 in my hand because I have a total of 3. S can take 2, okay, this S can also take 2, but I have only 1 to go because 2 plus 1 makes it 3. So I'm done with my electronic configuration. So how do I write it? I say energy level 1 has sublevel S and it has 2 electrons. Then energy level 2, okay, this is 2, and it has S and it has 1 electron. So you see the total is 3. These are the sublevels and these are the energy levels. Energy level, this is the ring, the main ring. 1 and then 2. So I'm going to start it again. I'm going to repeat it a little bit. We have nucleus, energy level 1, energy level 2, energy level 3, and energy level 4. Okay, 1, 2, 3, and 4. This can take maximum 2 electrons, 8, 18, and 32. It has the one sublevel S. This one has S and P, S, P, and D. S can take 2, P can take 6, 14 electrons. Okay, this is 6. So let's say I have 8 electrons in my hand and I want to distribute those 8 electrons. I start with energy level 1. Okay, energy level 1 and has sublevel S, and I put 2 electrons in that sublevel. Okay, then I jump up to the higher energy level, which is energy level 2. So energy level 2 has S and P. S can take 2, so I put 2 in here. So that makes it 4. I have 4 more to go. Okay, I have 4 more to go. P can take up to 6, but I have only 4 left because I have total of 8. And it's 2 and 2, 4 already. So I'm going to put 4 in here. And that gives me total number of 8 electrons. So how am I going to write this? I have 1, energy level 1, sublevel S. That has 2 electrons. Then energy level 2, sublevel S, 2 electrons. Energy level 2, again same thing, which is because 2 has 2s and 2p, which has 4. So if you put it together, it's 8 electrons. Okay, these are the sublevels, and these are the energy levels, energy level 1 and energy level 2. So this thing that you put together is called electronic configuration, means arrangement of electrons around the nucleus. So this is what I was explaining you here. The periodic table makes it much easier. Okay, so energy levels are decided by the period number. So anybody who is in period 1 has only one energy level. So this is what it is telling you, that energy level comes out by the period number. Okay, and the sub levels, there are 4 sub levels: S, P, D, and F. Okay, so your periodic table has S, both these are called S block elements. These elements here, right here, okay, are called D block elements. These here are called P block elements, and these are F block elements. Okay, S can take 2 electrons, P can take 6, D can take 10, and F can take 14 electrons. The exponents are the number of electrons. So we need to understand this, that your periodic table is divided into sublevels. This is sublevel S, sublevel D, this is sublevel P. You know, P can take 6 electrons. So everybody in this group will end up at P1. This one will P2, P3, P4, P5, and P6. So it makes it easier. This is all S1 and S2, and it goes from D1 to D10, and this one goes from F1 to F14. So this is how periodic table makes your electronic configuration much easier. We will discuss it in detail in the class. So this is what I was telling you, that you have your periodic table is divided into sublevels. So this is S block elements, these are D block elements, P block elements, and F block elements. So let's do the electronic configuration of hydrogen. Hydrogen is sitting right here. Okay, so this is S1 line, okay, column. Let me erase it. This group is S1 and this group ends up at S2. So hydrogen is sitting right here. So hydrogen is in period 1, so I write the period 1. Then it has the sublevel S, and it has only 1 electron, S1. If I want to do electronic configuration of lithium, okay, lithium will be, lithium has total of 3 electrons. So I start with the 1 first. So I will do 1s2 and 2s1, because lithium is sitting right here. So 2s1. This will be 2s2. This is where it will end. Helium is right here. So this is 1s1. The hydrogen is 1s1. So helium will be 1s2. Okay, beryllium is 4. It's right here. So first of all, you do 1s2 and then 2s2. So I will explain this in the class. We will practice on it. It's giving me a hard time. It's just taking its time. Okay, so these are the answers to page 4. We'll do it in the class. So orbital is the further, you know, like one energy level. Each sublevel has how many orbitals? As I just told you, there are 4 sublevels: S, P, D, and F. S can take, these are the sublevels. These are the number of electrons. S can take 2, P can take 6, 10, and 14. Pauli said that one energy sublevel can maximum hold, one orbital can hold maximum 2 electrons. So orbital is a space where it, you know, more defined space around the nucleus. And one orbital can hold a maximum of 2 electrons, and they got to be in opposite spin. Like if one is moving clockwise, the other one is moving counterclockwise. So we show that by the arrow. You can do a full arrow or you can do a half arrow, it doesn't matter. But one orbital one orbital can maximum hold 2 electrons. Okay, this was said by Pauli. You have to memorize the names. So if one orbital can maximum hold 2 electrons, then P needs 3 orbitals because P has total of 6 electrons. So if one takes 2, then I need 3 of those to make it 6. And then there is a scientist, his name is Hunts. Hunts said that when you have 3 orbitals and they all belong to P, okay, you have to distribute the electrons equally before you go back and pair them up. Okay, this is called Hund's rule. So this is Hund's rule. Okay, that the electrons got to be distributed equally before you go back and pair them up. So here I need 5 orbitals. 1, 2, 3, 4, 5. And I have to distribute the electrons equally before I can go back and pair them up. And here I have 7 orbitals. So I have to distribute the electrons equally before I can go back and pair them up. And when I'm pairing them up, I got to be in opposite spin. So one orbital, this is one orbital, can maximum hold 2 electrons and they got to be in opposite spin. This is said by Pauli. So orbital is the more defined space where we can find electrons. Okay, so this is orbital notation. If there are 2 electrons in a box, one must go up and then the other one go down. Okay. In p orbitals, there are 3, in p sublevel, there are 3 orbitals, and you have to distribute the electrons equally before you can pair them up. And then we will do the orbital notation here in the class. So this is the scientist foldable. So I will talk about this in the class, but I want you to take notes. So I want you to take a foldable and divide it into 6 sections and take these notes. And then you need to take these notes. And we will discuss all this in detail in the class. So you can pause the video and take these notes at home, as a homework. You can stop the video, pause the video, and complete this foldable before you see me in the class. So that's all for this video, and we will just go from here and do more practice of electronic configuration in the class. Thank you very much for taking these notes. See you later.